Hey, what's up? Mr. Myers is here, and this is the final video of Unit 7 in Calculus BC, Calculus Extended. We're talking about the alternating series, and there's actually a special test for alternating series to see if an alternating series converges. So an alternating series is any series that has that basically alternates from positive to negative. 3 of the elementary series are in fact alternating. So let's take a look at the alternating series test for convergence. So the alternating series test for convergence states that if the terms are all greater than 0, and the alternating series will converge if 2 things happen. 1, at some point each term needs to get smaller. So the next term needs to be smaller than the term before that. Now, it doesn't have to start off that way, but at some point it needs to change so that after that point, all of them start to get smaller. Second thing that needs to happen is that the limit as n approaches infinity of the term, the explicit part of the term, so a sub n, is equal to 0. Now, remember the nth term test for divergence stated that if the limit as n approaches infinity of a sub n is not equal to 0, then the series diverges. But if it was equal to 0, the nth term test for divergence was inconclusive. We didn't know if it diverged or converged. Well, this time, if the limit does equal to 0 and it's an alternating series, then we can use the alternating series test for convergence, which allows us to say that the series will converge. So it's kind of like, what happens if it, right? I think I said this before. What happens if that limit does equal to 0 when we're talking about the nth term test for divergence? In this case, if it's alternating, it's going to converge. So let's take a look at a couple of examples. So we've got an alternating series here, all right? -1 to the n plus 1 times 1 over n. If we look at this, if we look at the terms in this series, it's going to be 1 minus 1/2 plus 1/3 minus 1/4 plus dot, 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 right? Now, we could clearly see that a sub n plus 1 is in fact going to be less than a sub n, right? 1/2 is less than 1, 1/3 is less than 1/2, and so forth. We also know, so we're gonna either say this, or we could say, yeah, it's probably better just to say this right here. A sub n plus 1 is less than a sub n. We'll say in absolute value. I just want to make sure that you say that, just because some people might get confused and think, oh, a sub n plus 1, are you talking about -1/2, or are you talking about positive 1/2, or are you just talking about, because positive 1/3 is not less than -1/3. We're really talking about the non-alternating piece. So it's probably good that you just say in absolute value, the other one's less than the other, okay? Or a sub n plus 1 is less than a sub n. All right, now then that's the first thing. So the second thing now is we have to check the limit. So the limit as n approaches infinity of a sub n. Now a sub n in this is this part, not the alternating part, just the 1 over n. If you want, you can also say a sub n equals 1 over n, right? Okay, so what is that limit equal to? That limit is 0. So we're going to say that this converges by the alternating series test. If you want to abbreviate that, the AST, by the AST. All right, so this one converges. Let's take a look at another one. All right, so here we have an alternating series, so that's good. It's alternating. If we wrote these out, we'd have 2 minus 3/2 plus 4/3 minus 5/4, which do in fact decrease. So a sub n plus 1 is less than a sub n. in absolute value. All right, so the first part checks out. It is an alternating series. By the way, the first thing that has to happen is that it's alternating, okay? So if it's not alternating, you can't use the alternating series test. All right, the second thing we need to do is check the limit as n approaches infinity of n plus 1 over n. The limit as n approaches infinity of n plus 1 over n is actually 1, right? Gosh, what's going on there? That's equal to 1. And according to the nth term test for divergence, this is divergent. So this diverges by the nth test for divergence. Yeah, there you go. So this one doesn't converge. Doesn't pass the alternating series test for convergence. Okay. So folks, so far in our course, thus far we have 3 tests for checking on convergence and divergence. We have the nth term test for divergence, which we just talked about. We have a geometric series test, which we know diverges if the absolute value of the r is greater than or equal to 1, or the absolute value, we know that, blah, 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 I can't talk today. The absolute value of r is less than or equal to 1 if would tell us that the geometric series converges, and in fact it'll converge to a over 1 minus r. So as long as, like I said, r is between -1 and 1, which helps us find the interval of convergence for the power series that are geometric. Finally, we have an alternating series test for convergence, which we just talked about. It has to be an alternating series. A sub n plus 1 has to be less than or equal to a sub n. And the limit as n approaches infinity of a sub n must be equal to 0. So we've got 3 tests for convergence and divergence that we can use. And in the next unit, we'll go over the rest of them. Okay, talk to you later, guys. Bye. Good luck on your tests.